So we'll get this done and it'll be lunchtime. Come on in a little closer. Come on in a little closer. All right, so let's go ahead and get started here. This is turbine checkout. This will be the last module. After we finish with this module, go ahead and put your turbines back on. Make sure you put all the pieces back in there. We'll start with you. Come on up. So, what's the purpose of that heat shield that's laying there?
It's a shield to protect from the heat.
Okay, show me where it goes. And how's it attached in there?
How is it attached in it? Oh, I didn't detach it, but it looks like it's got one of these. Not exactly sure.
You're talking to yourself. I'm not hearing it. But
Yeah, I am talking to myself. It looks like it's got spots where it connects right into the deal. Right here.
Okay, so why do they mount it on those pins?
I'm sorry, say that again?
Why do they mount it on those pins?
To keep it from turning?
Yeah, keep it from turning. It's another real reason why they do that, though.
Okay, what's the real reason why they do it?
Expansion and contraction.
Expansion and contraction. So let's go ahead and screw one of those pins out of there. Go ahead and put that thing back in there temporarily. You'll see why, because it fits in there kind of loose. It's not real snug. It's two pins. You're going to need to take both out. So if that thing was it was solid or rigidly bolted in there, what would it do?
What do you mean it would do? It would do its primary job to protect the heat shielding, so do a primary job to keep the heat.
So we got a heat shield. What are we shielding?
We're the bearings. Okay.
The bearing housing. Okay, good, good. So if that thing was rigidly bolted in there, he says it's just so the thing could float around for expansion and contraction. What do you think?
Well, I think it would, as everything, I mean, not only is it going to help redirect the air, it's going to help, obviously, protect the bearings. It's going to,
Yeah, but why do they bolt it in there like that? So he says it's so that it can expand and contract and move around in there. Do you want it moving around in there?
I don't think you'd want to move it around in there. Right. You're wrong. Why would you?
He's saying you're wrong.
No, I said it could be wrong.
You want it? You could crack the shielding itself if it's bolted in there rigidly. You want it a little bit free floating for when it expands and contracts, so that it doesn't. It's got room
There
to
you
be
go.
able to extend it.
I would agree with him on that.
So you agree with that?
Yeah. I
Okay,
agree with
good.
that.
That's a good explanation. All right. So next up, show me the nozzle guide vanes. You go ahead and pull that.
It's right there.
Go ahead and pull that heat shield out of there. And hand it over to Mr. Kwok. Okay, so the nozzle guide vanes. What do the nozzle guide vanes do?
Just direct the air. Those are nozzle guide vanes. Just directs the air to the direction of the turbine rotation.
Okay, so they set the airflow up for the turbine blades then, right?
Correct.
Okay, good. All right. Hand the heat shield over to Mr. Kwok. So tell me about the construction of that thing, Mr. Clark.
You mean like what kind of material? and all
Why is that one piece doubled up there on the other, that side there, yeah?
Um, kind of the spot where, it's doing this way for the cooling purpose,
For what?
for cooling purpose.
Cooling, okay. So that's what the whole point of the thing is. Why do they have a double surface there?
I mean this and this.
Yeah, between the two, what's the deal? Why do they need that piece on there?
It creates a buffer zone, so as the flames or the heat coming from the combustion basket,
Mm-hmm.
it's sort of help cooling the shield down.
Right, helps dissipate the heat's what it's gonna do. Yeah, exactly right.
The hottest part, you don't want to burn through it.
Yeah, you don't wanna burn through, put a hole in it, right? Because if you put a hole in it, what would happen?
Well, then you end up putting a hole in the bearing shield and then cooking the bearing.
Yeah, you'd end up frying the bearing. Yeah, exactly.
Yeah.
It's a heat shield for the heat shield, exactly right, yeah. Let's see here, who we got next? You'll be next. So, show me, is this your engine here, or is this somebody else? Is it? Okay, cool. Show me the oil nozzle for that bearing there. I'm probably sitting here right in front of you here.
This guy
Good.
right here.
Okay. You guys take it out, or did you ever take it out?
We took it out and put it back in.
Oh, okay.
Yeah.
You got a wrench? Let's go ahead and take that out of there.
Just got a wrench.
Anybody? So you got a quarter inch box, or?
Anybody?
So we'll just keep going while we're waiting here. It's from Myrick. So where's the EG or the TIT probes for this thing? Are they around here somewhere? Does this one have any?
The thermocouple?
Yeah.
No, I took them off. There.
Oh, so they are here somewhere. It's a box in. You got a box in? Box in quarter? Anybody? Anybody?
This is 516. 516 right here.
Yeah, you need a quarter. That's a little screw there. Awesome. Awesome.
He's good, he's got one, Ed.
Got it.
Thank you, Steve.
I do for you guys.
I do without you.
Okay, so does that look like a nozzle? That's not a nozzle.
No, that's something. That's something else. The nozzle's on the other end.
Anybody know where the nozzle is for this thing?
Where it goes, or
Looks
where
like it's
it is
been taken out.
currently? Yeah, it's not even on.
Where's the spare parts for this thing at? They're down here. Why don't you
I don't think we
dig around down there when you get out of your way here? Yep, it's locked.
Well,
I get it, Steve.
yeah, this is for the oil pump.
Well, while we're on the topic, Jake, so there's an oil sump on this thing. You know what it looks like, right?
Yes, sir. It's
The
on
little
box.
can?
It's on the box, yeah.
Yeah. What's that all about?
So you're gonna get 2 of these 5 veins are hollow, and the vein for the oil. So your top one is gonna feed. It's gonna be a small skinny tube. It's gonna feed down into your bearing housing.
That's a nozzle, right?
Correct. Yes. It's going to drip the oil onto the bearing housing, and then it's going to go out the other vein, and it's going to
Okay.
hit into the sump. But it's going to have a bigger diameter in the tube because it's going to have air mixed into it, and it's going to be hot. So it's basically going to reroute it back through the turbine, and then until it cools down to the point where it's back to being that pure oil that's going to be.
How does that air get into the oil?
Because it's dripping on the number 8 bearing, and because it's spinning so fast that it's going to be it's kind of like whipping up cream
Okay,
with a
making it frothy then. huh? Yeah,
exactly.
Okay, good. All right, so it goes into the can, kind of separates itself out. Let me take a look at these here, see what kind of shape they're in. Looks pretty clean. So, Mr. Myrick, we'll give this back to you here, or we'll give it to you. So tell me what you see with that one nozzle there, the small nozzle.
This one?
Mm-hmm.
It's directed, points in a certain direction. No, it's directed to shoot that way.
Oh, okay.
So if that nozzle is really clean, it'd be kind of silvery color, silvery gold maybe. But it's what's it got starting to cling to it there?
Carbon.
Okay, carbon. Mr. Booz, what is that? Where does that come from?
Carbon buildup?
Yeah.
It's depending on the temperature. If it's at a certain temperature, well, if it's lower than the specified temperature, then you'd be good. But then if it's higher, you have, I guess, carbon.
So it's carbon, building up carbon on there. And so what do we call that?
Coking.
Coking. Yeah, coking. First time I seen him smile. That was good. That was good. Okay, pulled that one out. All right, so Mr. Floth, why don't you come on up here? So the turbine mates. So this is stage what and what on this piece, this module right here.
This one right here is the first stage turbine.
First stage turbine. Okay, how many wheels in there?
Two.
Two. So it's 1 and 2. And then show me where 3 and 4 is.
These are the vanes, and then 3 and 4 are in here.
3 and 4 are
Yeah.
inside.
Yeah.
And so this one here turns what?
The gas producer.
Gas producer.
The-
How do you
the
know that? Give you a tip. Stick your finger in there and pull that shaft out.
This shaft here?
No, inside.
In here.
Yeah, just bend your finger. Give it a pull.
Or pull this out?
Yeah, pull that. That's it. So that's the shaft that couples the compressor to the turbine. Okay.
Yes.
But the second turbine, the second set of turbine there is known as what?
The power turbine.
Power turbine. Okay. So is that shaft turning faster than the power turbine, or is it turning slower, or are they coupled together?
Faster initially, but they're coupled together sometimes. Well, not mechanically coupled together, but fluidly airflow.
Okay, good. It's got a fluid coupling.
Yeah.
Okay, good. You're safe.
All right.
Come on up. It's your turn. So now between these two turbines, we have a lot of gas going through these turbines, right? A lot of high pressure gas, a lot of high velocity. It's all rip-roaring through there, headed for that exhaust. How do we keep, there's some seals at play here that seal those shafts and seal the turbine from one another, even though we have a rotating shaft. Where are those seals at? A couple of air seals. So remember, we want to keep the air in the turbine. We don't want it going someplace else, right?
No, I don't remember.
Okay, Mr. Maniscalco, save it. Okay, so you guys, we haven't talked about seals yet, so we got a couple labyrinth seals there, okay? And so we'll be talking about seals here down the road real quick, but just to fill you in, so no foul, you're safe, because we didn't talk about those yet. But on an air seal, you have a bunch of knife edges or sharp edges. Go ahead and put your fingers up there, you'll feel it. Go ahead, it's okay, it won't bite you. Okay. Now those run very close, those edges run very close to its counterpart, which is inside this end here. So I want you to lay that thing over carefully and look down in there. So it runs, if you want to come on up, take a look. So down inside where he's got his finger there, go and put your finger back in there again. There's a real close fit between that surface and those seals. And those seals run within just a few thousandths of an inch of that surface. So air tries to get across where the knife edge is. We're forcing air across that knife edge. And so what kind of a duct is that? It's going to be a converging duct, right? So the velocity is going to increase, pressure is going to go down. But when it falls into that wide space there, between those knife edges, what happens to the pressure? Pressure goes up, velocity does what? Goes down. So every one of those little knife edges, every step that it takes, what happens is it's building pressure across that seal, so that air can't get across there anymore because it's building up a head wall there, so it can't escape across those seals. Says we're trying to use air to drive the gas producing turbine, which is going to drive the compressor, right? And that's what keeps this whole machination going, keeps the whole thing running here, because this thing really, what we want out of it is enough power to drive a drive shaft, to drive a gearbox in our case here. And so we have to have enough gas left. We can't afford it to leak. We have to have enough gas left to drive 3 and 4 wheel, right? Do you guess? Otherwise we don't have any power to run the drive shaft for the transmission, which goes up to the rotor head. Okay, so that's kind of air seal in a nutshell, and so just kind of put that in the back of your mind and kind of remember that, because we'll be getting air seals, and you'll all be getting to deal with air seals. These guys working on the odd jobs down there have already dealt with that. Show me one of the vanes. So we have a nozzle vanes, nozzle guide vanes. So I saw the nozzle guide vanes. Who pointed that out? Somebody stuck their finger down. Okay, so you showed me the nozzle guide vanes. Show me one of the nozzle vanes.
Nozzle vanes?
Yeah. So on a compressor you have, excuse me, you have stator vanes, and then you got the rotors. So we have rotors in there, which is a turbine. What would be the equivalent to the stator vane in a compressor?
I thought it was just a stator and a rotor.
So when I took my A&P test, I've told some of you this. It's a little story on me, right? So I had a guy test me. He was at City College, and I was sitting there one night after school, and it was dark, and it was raining outside, and he held up this blue fitting, right? And he says, well, how do you know this is an AN fitting? And I said, well, it's blue. He said, okay. He says, tell me another reason. I said, well, it's got 37.5 degree cone on it, right? And so it'd take a 37.5 degree flare, right? AN fitting, right? He says, well, something else. And I sat there and he just held it. It was like he was eating a sandwich while he was holding this thing, just sitting there. And I'm like twisting in the wind, you know. It's like, oh shit, you know, I can't think of anything else. And he says, what does it say right there? It says AN on it, right? That's how I knew. You don't have to laugh. It's okay, because I felt pretty stupid, but that was the other thing. So just point. Where's the vein there? Where do you see a vein?
This is a vane.
It's like the calf roping, you know. You got it. You got it. So that's a nozzle vein. Yeah. Yeah. Nothing too hard. Okay. So you're off the hook. You got it. You got it. Yeah. No, you're good. You're good. I already had you. Sam, you're up. Why do we have 4 thermocouples? I don't know where they are, but why do we have 4 thermocouples? You guys got one taken apart over there? And what are they called?
The thermocouples are probes. They're the hot junctions, and these are the cold junctions. These connect to the gas producer, just to take the average, or for the probes take out the average to get the TOT.
And they're what? What are they?
To get the turbine outlet temperature.
Yeah, TOT, right? Turbine outlet temperature. Right. So there's a number of different kind of ways we take temperature, right? Just like on people. I had woman stuck a thing in my ear today, took it in my ear, and then she rolled a thing across my forehead. And some of you have been privy to the other way, not the one in your mouth, right? And so there's like 4 different ways, right? The same thing with these things here. So you have turbine outlet temperature, and what they do is, in this case, so they put the probes in between the turbines. Some of them you get the temperature after all the turbines at the ends where it comes out, and that's called EGT, or exhaust gas temperature. And then some of them you have turbine inlet temperature, TIT. Okay, so this is TOT here. And some of it's called interturbine temperature, or ITT. So what we're doing here, this can be factored as a method of seeing what the power production is of the engine based on the temperature of the gas coming through the turbines. Does that make sense? And there's a book. Pilot has a book. He knows if he has so many degrees, he has so much power output coming out of that engine from the temperature. Okay. So why do we have 4 of them?
Well, it's positioned throughout the whole turbine, so it just gets an equal amount.
So it gets a kind of a spread out view of what of the temperature is. Okay, good. And so go ahead and tell me why. So she's kind of danced around it here, but tell me why you might have 4 of them. All of that's right.
To average it out.
So it averages, right? Okay. What would happen if you lost one?
Yeah, so.
Because you got kind of high temperatures there, right? You could burn the end off of it, and they do. Well, you're off the hook, but it's her turn now.
You get a lower reading on the indicator?
Would you get a lower reading, or would you still get the same reading because you're enjoying the redundancy?
Oh, I see. Okay, yeah, that makes sense.
Yeah, so you do. So if you lose one, you still got a good. You've got, instead of 4, you've got 3, but you're still getting a positive temperature reading, an accurate temperature reading. So you have a redundancy. You have a good way to measure it all the way around in a consistent fashion, because you could have hot spots in there, but this is going to average them anyway if you do have hot spots.
So are they wired in parallel?
Yeah, they're all wired parallel together.
Okay.
So if you lose one, no sweat. Now when you don't repair them even, because they're all swedged together.
Right.
All you're going to do is just change the harness with the probes.
But if you lose just one of them, would you be able to see a difference, or will it be?
No,
You
no.
just really won't know until
And you can see how hard it is to take it off. You just take it off and test it. That's all you do. Yeah. They have a tool called a jet cowl, and a jet cowl will attach to each one of those probes. It raises the temperature to a specified amount. When you do that, you know you can switch it on the jet cowl to see what the probe is reading, each probe in turn. So you know if you have a faulty one by just checking it with the jet cowl. That's all. It's real easy to do.
Is that a annual?
Some of you do it at an annual, yeah. And certainly in an overhaul, you just throw the whole thing away and put a new one in there. Because they burn the ends off of them. Okay, Mr. Winks, I think you're, oh no, you're next.
I'm next.
You're next. Tell me what the heck is this little tube? There's 2 of them on the side of this turbine housing here. There's a couple of things that it does.
Several things.
Yeah.
One of the things that it
Turn,
does.
turn that around. Show everybody what that looks like. A couple little worms on the side there.
These little tubes right here. So one of the things they do is it actually, there's a chamber inside of here that feeds called the thrust balance chamber, I think is the name of it. And basically, as the engine's running, this is trying to...
That's thrust, not rust, right?
Thrust, yes.
Yeah.
The thrust balance chamber. It's the first and second stage tend to push forward, and that loads, that axially loads number 8 bearing.
Mm-hmm.
And so to help reduce that, some of this air is sent into this chamber that's back inside of there, or is it part of right here?
Mm-hmm.
I think it's sort of both. Next to the labyrinth seals, and that helps push against it and take some of the axial thrust off of that bearing.
So it keeps it centered in there.
Keeps
then.
it centered in there, and then
Yeah.
it also provides cooling through the struts to help keep the struts cool so that they deform less. And there was the third one, but I don't remember it.
Okay, good, good. Anybody know what the third one is?
It wasn't balancing. Or?
It helps balance the pressure.
Balance it. That's right.
So what you've got here is you're using a lot of the energy, the kinetic energy from that gas is being consumed by those first two-stage wheels, right? And what happens is this is sucking up enough to where that's not seeing as much air pressure coming across it. So you still have a fluid coupling between 2 and 3, but you don't have you kind of lose a little bit of air in there. So this also helps to add a little bit of air to 3 and 4 so that it has plenty of power for power production on the engine. Okay, so it does all those things, and it was actually they only had one originally, and then they had to go to 2 because they found out that the wheels, the 1 and 2 stage wheels, are starting to move back and forth as the power came up and came down. So these little engines here get more throttling than say a big turbofan does. So a big turbofan is going to run at kind of a steady state for long periods of time, hours and hours and hours. These things here, the pilot's going to be rolling the control, the power on and off of these things periodically. And most ordinarily, these things are governed to where they'll run at about 100%, 80 to 100% all the time. But if you need that extra little squish of gas, the pilot has that. It's like a motorcycle throttle, or a roll grip is what it is. And so you can add a little bit of extra air to it.
Here's one more question.
Yeah.
Does it also feed the labyrinth seals?
It's also pressurized with a labyrinth seal.
Okay, right.
Yeah.
Then that's just in this case. That's just 6 and 7.
6 and 7.
Because 8 is a different story.
8's a different story together, yeah. That's a sealed bearing. Okay, so who do we have? Mr. Winks. How many do we have more? 1, 2, 3, 4. Let me see if I can gin up some more questions here because we're just about done. Mr. Winks, let me ask you this question. I don't know if you read about it or covered it or not, but there is a line that tells the engine that the engine is running. It tells the fuel control that the engine is running. What's that line called, and where does that pluck its sense off of? There's a sense line, is what it is. You got him? So go get Mark. I think he's hiding in his cave over there.
I was going to run the fire extinguisher for Mark.
Oh, were you?
I'm gonna hang out
Okay,
there.
good. Yeah. Might spritz a little more water out there too.
You got it.
So it's called a burner pressure line. And that burner pressure line has got to come off either at the end of the burner or at the turbine. So that what the fuel control has to know is the engine running? What kind of power production do we have in the engine, so it knows how much fuel to be adding to the engine. So if the burner pressure line goes, the pressure in that line goes down, what happens to the fuel flow?
Increase the speed.
Too rich, right?
Yeah, so what will the fuel flow do? Hey, Norva? Here he is, here. So what will the fuel flow do? I'll just ask you. What will the fuel flow do if the engine suddenly senses that there is no more burner pressure?
It'll cut the fuel.
Cut the fuel off, right? It'll think the engine's not running at full speed. It's going to sense that it's running at speed because the gearbox is turning, but it won't know at what speed, right? All it does is spin there's a governor, flyweight governor inside the fuel control, and it's just telling it to give it that much fuel, but based on the pressure that it's sensing from the burner pressure. So in this case, it's sensed off of one of these lines here. I don't see the line here, but that's immaterial. As long as you know that there is a burner pressure line that will be connected to the fuel control. Now, I had a friend. Did I already tell you the story about a friend of mine, a helicopter? Okay, so at SeaWorld, they used to have a helicopter, used to do sightseeing out of there all the time.
Oh, yeah, burn the line off.
They burned the line off, yeah. So I probably told them another class you were in. So somebody had cut the line, it was a rigid,
It was this class.
was it this class? Okay, good, well, I'll stop telling the story then.
I don't
But know
remember this
that, if you have a line like this, you can't just replace it with a piece of rubber hose and a couple of hose clamps. Don't ever do that. Just be super, super careful about that.
So does that run into the governor?
Yes, runs right into the side of the governor.
I think that one?
Yeah.
Probably
You-
one of those.
Lonnie, could you talk a little bit about the diaphragm?
The diaphragm?
Yeah.
Which diaphragm?
I don't. When we were talking about the diaphragm, we were a little confused at where it was located and all that stuff.
I think in the chamber. Do you mean the chamber inside?
You guys remember this conversation?
What conversation?
I heard diaphragm
Alright, never mind.
Yeah.
Obviously, no one knows what I'm talking about.
Pressure line to the fuel control.
What's that?
Sorry, the burner pressure line to the fuel control. That just a quick recap on that story. That thing got melted away.
Yeah, what happened was, the helicopter guys had some maintenance done on it, and the line was somehow damaged or other, so they cut a bad section out of the line, out of a piece of stainless steel line.
Yeah.
And they slipped a piece of hose over it.
Oh, okay.
Mil 6000, I guess, is what they used. And Mil 6000 is just a neoprene hose. And of course, the burner pressure line is going to be what? Hot, right? Yeah. So it just melted a hole in the rubber, and pretty soon, when it melted the hole, now there was no more pressure in the line,
Which means no more fuel.
No more fuel.
which meant no more fuel, and the airplane, the helicopter came down like a sack of crap, right? Hurt a lot of people. Yeah. Okay, so next, you'd be next, Brian. So with regard to noise, we've got the gas going across 3 and 4 wheel there, and it comes out through this exhaust. Now this exhaust on the helicopter has another extension pipe that comes off and takes it overboard. But based on the inside of the shape of that pipe, what is that going to do noise-wise, and why?
It's going to reduce noise because of because of the way it's flowing. It's smooth and everything, and it's like an expansion chamber too.
Okay, so it's a diverging duct in there then, right?
Diverging duct, yeah.
So the velocity is going to go down.
Velocity is going to go
And
down.
so what's the culprit? You got pressure and velocity. Which is the culprit that causes noise?
Culprit velocity.
Yeah, velocity, right? Velocity is what's going to make the noise. So this thing would be a screeching son of a gun if it didn't have some way for it to expand that air after it comes off the turbine wheel. So the turbine wheel, we're trying to have pressure or velocity to drive it.
Drive turbine wheel. Velocity.
Yeah, we want velocity to drive the turbine. What do we got left? Okay, we got two left here. Let me see here. Might be your lucky day, guys. Who's got a question for him? Anybody?
We're also talking about the saddle. I don't know if that is more about that.
Saddle?
Yeah.
Two things that are called saddles.
Yeah, which one are we talking about here?
Well, because are you talking about the extra long blade that's called the saddle?
Yeah.
Or
when it creates the little
Ed,
cool air pocket.
because they also called the flanges the saddles as well.
Right.
Well, I think Drew was referring, when we talked about it, he's referring to the extended blade.
Extended blade.
Right.
on the-
Yeah, what the purpose of that was.
The extended vein, you mean?
Yeah. Just creates that little air pocket to cool down that individual blade that it's on.
So, go ahead. What's it do?
So the edges, they're extended, and basically, I guess from what the reading in the manual says, that the air will hit the extra edges, and then it will create a kind of like an air blanket over the blades, which will cool each individual blade. So the manual refers to it as a saddle. I think it's referring to it as that little air pocket in the saddle. or
It's a little lump there in the case, right?
right.
Right, like here, around the outside?
Yeah.
Got it.
Yeah. Yeah, it just diverts the air around the outside there is all it does.
I got a difficult question. Where does the air for the number 8 labyrinth seal, the number 8 labyrinth seal come from?
Where does it?
I know the answer.
Go ahead.
Yeah, you
The
can answer.
answer for the air for 6 and 7 come from the balance tubes. The air for number 8 comes from the suction from the scavenge pump, because it says that the scavenge pump is so strong, or it is considerably more. It sucks considerably more than the amount of oil in the number 8 bearing, and so it brings air along with it, and they use that air as the labyrinth seal.
Through the line.
Yep.
Anybody else? You got a question? I'm out of questions, guys. I don't have anything. I got nothing else.
I have a question.
Why is it our lucky
I have
day?
a question. Can we go to lunch now?
Yeah, I was just gonna say,
Well, why is it our lucky day?
yeah, go ahead.
Temperature when the airflow is up to normally how much?
What's the temperature coming out of here?
Yeah.
It's gonna be about 1,500 degrees. But it'll drop very quickly because you have
That's good, Ed.
Yes.